Okay, so we're in our organic chemistry unit. We've been talking about carbohydrates and lipids and proteins, nucleic acids, and what differentiates these different organic molecules from one another. We know that they're all made up of carbon, hydrogen, and oxygen, at least. Right? Many of them also have nitrogen, phosphorus, sulfur, etc. But they all have CHO. So we need to figure out how we can tell between carbs, lipids, proteins, nucleic acids. It's important that we understand that these are macromolecules, which means that they are very large. Sometimes they're in chains of carbons, sometimes they're in rings. But when we're identifying them, let's say if they are a chain, it's what branches off this chain of carbons that makes these things so unique. Now, carbon itself, recall that carbon has 4 valence electrons, so it has the ability to bond here, 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 and here. So it's a very unique atom in itself. Lots of things can bond off of these chains. They can form rings. So lots of different shapes, lots of different diversity of hydrocarbon molecules. And that's what makes this such a unique element. Alright, so we're going to look at the things that do branch off of these chains and off of these rings. And those are the functional groups. So that's what we need to look at. First one is an ester. Now we're going to talk about esters. Here we've got carbon. Oh, let's put the pen back on. Carbon is bonded to an oxygen, to another carbon, and then let's say the molecule continues this way. So this is kind of the rest of the molecule, and then the rest of the molecule continues this way. So that's signified by the R. But one of these carbons has a double bonded O to it. Could be this one, could be that one. But if you see this series of atoms in the middle of a molecule, that's going to signify an ester functional group, and it's going to cause the molecule to act a certain way. An ether. Well, it's going to start out very similar to an ester. The rest going that way, the rest going this way, and that's it. Okay, there's a double bonded O on the ester. There isn't one on the ether. An amino group. The rest of the molecule up to a carbon, a nitrogen with hydrogen bonded off to it. This is our amino group. These are really important. Amino groups, or amine groups as you might see them called, are on amino acids. I'll put that up here. Amino acids, if you'll recall, are the building blocks of proteins. And this amino part comes from the fact that they have an amino functional group on them. The acid part comes from the fact that they have a carboxylic acid group as well. And we'll talk about that once we get to it. Amide. Similar to an amine or an amino, there's our amine. In order to make this an amide, boom, double bonded O. So this whole thing would then be our amide group. Alcohol. This is sometimes called a hydroxyl group. The rest of the molecule, carbon with the OH. This is our hydroxyl group. Very important functional group for dehydration synthesis. It's going to donate a hydrogen most times. Here's our carboxyl group, sometimes called a carboxylic acid. And this is the one that gave amino acid its name. Let's do this. Here was our hydroxyl, and in order to make that a carboxyl, put a double bonded O off that C. Now if we go this way, I'll show you an amino acid. Let's put a carbon, let's put a nitrogen, and our amino group. So now we have amino acid. Okay? This is your carboxyl group. An aldehyde. Similar to a carboxyl group. Double bond O. Instead of this being OH, it's simply an H. Here's your aldehyde. Ketone. Rest of it going this way and this way. Double bonded O off that middle carbon. There's your ketone functional group. Acetone is called acetone because it has a ketone in it. A methyl group. These can get a little bit tricky identifying where a methyl group is. But a methyl group essentially is just a CH3. Sometimes it's written that way. Sometimes you'll see it with the hydrogen actually drawn out. Now, spotting a methyl group can be tough because you need to make sure that it differentiates itself from the main carbon chain. So if this is the main carbon chain, and if we put all these carbon and hydrogen bonds on there, remember these are very energetic bonds. Put some down here. Now, let's say right here, CH3. Here's our methyl group. Here's our functional group. Here's why. Find the longest chain of carbons. Well, we have 1, 2, 3, 4, 5, 6, 7. That's our longest chain of carbons. This is coming off that longest chain of carbons. It's differentiating itself from that longest chain of carbons. So it's a functional group. If we numbered it a different way, if we went 1, 2, 3, 4, 5, 6, that's not the longest chain. If we went 1, 2, 3, 4, that's not the longest chain. This is the longest chain of carbons. This is differentiating itself from that chain. So that is your functional group. Make sure that it's not a part of the longest chain of carbon. Make sure that it's differentiating itself from the longest chain. And that's it. Those are your functional groups. Those are what differentiate these organic molecules from one another and what cause them to have different behaviors.